Hi everyone, I'm Miles. I work as a data scientist at Jumping Rivers, and I'm really excited to tell you about diffify.com, which is our new website for comparing package releases. So I'll first provide a bit of motivation. So let's say you've been working on a big Python project, everything's been going really well, but then one day you log on and find that suddenly nothing works. So you do some digging and you find that one of the project dependencies has been updated, and that update has introduced a breaking change, which has caused the code to crash. So I'm sure that's painfully familiar for a lot of you. So if you're lucky, there will be the project dependency will have a news file or maybe some GitHub release notes explaining exactly what has changed between the two versions. But unfortunately, this is not a guarantee. So this is where Diffify comes in. So the idea behind Diffify is at the click of a button, you can compare any two versions of a package. And this will allow you to discover breaking changes that have been introduced and also new features that you could incorporate into your workflow. The website launched in April to do, initially just to do version comparisons for our packages on CRAN. But I'm very excited to announce that we've just expanded this to Python packages. So currently we have the 1,600 most popular PyPI packages according to download stats. And we are looking to expand this to all of PyPI one day. So I'll just give you a live demo. So let's say your project relies on matplotlib. You update matplotlib from version 3.3.0 to 3.5.0 and nothing works. So let's use Diffify to find out what has changed between these two versions. So I'm going to go to the home page, which is just diffify.com. Because we're doing Python packages, I'm going to click Get Started with Python, and I'm going to enter my package, which is matplotlib. For the later version, we can set this to whatever we want. I'm going to set that to 3.5.0. Earlier version, let's use 3.3.0 just for the demo. And Diffify will give you a full breakdown of the changes to the package dependencies, the functions, and the classes. So looking at dependencies, we can see the Python version requirement has changed from 3.6 to 3.7. Looking at the required package dependencies, we can see, for example, the NumPy version requirement has changed from 1.15 to 1.17. Looking at functions, you can see 8 functions have been added between the two versions. 18 functions have changed, and we can filter this down to just the changed functions. So, for example, we can see that the pyplot.grid function has changed. So expanding the details, we can see the function arguments, and we can see that the first argument has changed. So it's no longer called B, it's now called visible. So that is potentially a breaking change. And you can also see changes to the package classes. So we can see 44 classes have been added, for example, and you can click on the methods, and this will give you a pop-up which will list all of the methods that belong to that class. So that's just a quick whistle-stop tour. If you spot any issues with the website, you can just report these here. That will take you through to the project GitHub. So just to wrap up, looking to the future, we're hoping to expand this to all 350,000 packages on PyPI, which is a little bit ambitious, but fingers crossed. And we're hoping also to extend this to other package repositories, so beyond PyPI. And there's no reason why we couldn't expand this to other languages. So we already do Python and R. Why not expand it to JavaScript, Scala, Julia, and so on? Finally, I'd like to acknowledge that this was a team effort, so I'd like to thank my colleagues at Jumping Rivers, including Parisa, who's here at the conference with me. And if you haven't already, you can visit us at our stand just outside to hear a bit more about our company and what we do.
I have one question. Sorry, what's your name?
Miles Mitchell.
Miles, that's the first time I've seen someone do a lightning talk under 5 minutes with a live demo and actually hit what most people only hit in an hour. That's outstanding. Give him another round of applause, please. Sorry, that's an unbelievable talk.
So if you go to speed.python.org, you can find the speed improvements of particular module over time. But in real world, this is not that much useful because you are using hundreds of modules, and performance gain on one of the module will not help you the overall performance gain. So I thought I'll write a glorified version of Hello World and see how it works. So what I did is I set up a bunch of programs 7 different types of tests to find like how it is like compared to Python 3.9, 10, and 11. So the first one is like a PyPy cache. So for example, what this does is like it gets like 720 MB of data from all Python package index data, and it does is like find top 10 home page domains, and then find license frequencies, and does some of IO operations. And if you do some benchmark, and you'll find out like by 3.9 compared to 3.9 and 3.11 is 6.71% time faster. So before getting into more details, I'll say like how did I run this test? I ran this all in my computer, like i7 16 cores. None other programs were run, and I used this command line tool called Hyperfine. Hyperfine is a Rust library where you can use it to benchmark commands and see how fast it is. And one other thing to notice, like I had warm up as 1, and number of runs as 10. That is one, and I used median as a value, not as mean. So medians are much better compared to mean. So if you, so in this case, like it was like 6.5% speed improvement I was able to get in Python 3.1. And this is an interesting case. This is just a pure IO bound operation. You just take some 700 MB of data and compress to bzip and try to see the performance. And here, Python 3.1 was the slowest one. It was not the fastest one. 3.9 was fastest one, and it may be due to because it's a C code. You don't get any performance improvement of just migrating to Python 3.11. Next is same like Postgres. I have like JSON data. I just want to import all the data to Postgres. So I wrote a small program, and then in the result. Is like compared to 3.10, 3.11 is like 3% or 2.9% faster, slight improvement. Same with PySQLite utils, like if you use dataset project, it is underlying library, and you can get like 3% faster. There is like a couple of other comparisons as well. In general, like conclusion is like if you are using 3.9, it is better to migrate directly to 3.11, and you may see some performance improvements. And if you are using bzip for compression, don't use bzip, use ZSTD. That is like 50 times faster doing any compressions, and you can save a lot of CPU in that. And to my surprise, like even like some performance improvement which I was not expecting was PsychoPG. There are some performance improvements, and yeah. That's it. And final one is like I'm trying to benchmark like Python and Flask, Django test runners, seeing how fast it is. I'm getting like 5 to 10% speed improvements in 3.11. So maybe you should consider migrating your projects to 3.11. Yeah, thank you.
Great stuff.
So yeah, teaching data science at PyCon Ghana. So that's what I did last month. And so. You know, there's my contact detail and stuff if you want to contact me. I don't know why I'm still like on Twitter, but maybe I am still on Twitter. So yeah, okay. So Humble Data is, what is Humble Data, right? You can actually, I forgot to put the link of the website again. So if you want to find us, it's humbledata.org. So just one word, Humble Data, and then .org. So what are we doing? What is this? Like, you have never heard about that before. It's actually a workshop. So we haven't, you know, we are not a company. We are like we're just a workshop that we have basically created. So it's a data science workshop for absolute beginner. Do any of you know Jungle Girls workshop? Yes, of course. So the idea is similar, but we do data science because not everybody wants to do web development. So it's basically we're using Jupyter Notebook, and people can work on them by themselves, but the idea is that if they come to the workshop, then they would get to meet people. They would meet their mentor. There would be a mentor helping them, and they also like work with other mentees so they can build friendship. So basically, we don't want it to be just be like teaching data science, but we also start a community so they can keep on learning and improving in the future. Also, we want to empower people, so the people who have been to mentee, who have been the learners before, we encourage them to become the mentor the next time around, so you know, they know the struggle of like being an absolute beginner who have never ever write a single line of Python before in their life. Some of them don't even have Python on their laptop. It's like, oh, what is Python? So yeah, so that's why the mentors can like they are not very expert of Python, but they just like know a little bit more, and they can help the people who are starting from zero to get started. And they also feel empowered themselves because last year they start from zero, now they are a mentor. So we started this effort in 2020, but the idea of the whole workshop is people sitting together in a room, right? So it's very rough in 2020 because we can't sit in a room together. So what we're gonna do? We're gonna do what everybody's doing, using like online, like Zoom, all these things, Discord. So we have tried it to partner with different conferences like PyCon US, PyData Global, and PyCon Africa in the past. PyCon Africa is really tough because internet there is very few and far between. So back in person, so luckily now pandemic's over, thank God. And this year, if you have been to EuroPython, you have seen us. My friend Lace is running a workshop there, so it's the Thermal Data workshop. And also, I've done it in PyCon Ghana last month. So this is what I'm going to show you. It's the beautiful picture of people being so happy. They're like, you see, like, people that love selfies. So we took like millions of selfies. I can't show you all of them because there would be too many.
That guy looks really happy. Sorry, right? He looks like the happiest man.
I'm going to that in a bit. But before that's after picture, right? The before picture is this one. They are working really, really hard. You can see that guy is like exactly what you point out, right? Scratching his head. It's like, they are serious. They are not just here to have fun and have free food. They're here to learn data science, right? It's like, so that's good. That's a good thing. And so by doing that, what have I learned? So why am I doing that? And like why we can be successful doing this? I think something that I learned from Ghana is that the organizing team there is amazing, and we need local organizing teams for help because I can't do everything by myself. I can't recruit local mentor there because I don't know, that was my first time in Ghana, right? Know nothing about the country. So also we need to recruit people who come to learn, otherwise that defeat the purpose of what we are doing. We have a lot of reliable mentors. They are all very amazing. You can see the picture before, the person next to that person who was scratching his head is really patient and helping them go through all these troubles and help them to install Python. So we had an installation party the day before the actual workshop, and that's very essential because people have various laptops, so some of them take a long time to install Anaconda. So having an installation party before they can start to know each other, warm up to each other a little bit, and they can install the machine, the Python on the machine, and it's ready to go the next day. And people are very happy, as you can see the after picture, not the before one. After picture, they're all very happy, and So how can you help? So if you think that, this is a really good thing and I want to be part of it, let us know. If you have a local community there, maybe young people or people who want to learn data science, but they have never, ever done Python before, then it's a good opportunity. We can do Humble Data Workshop with them. And, but all the workshops materials are actually hosted online. So if you're expert in data science, feel free to have a look. And if there's any mistakes or anything we can explain better, you can make PR. PR is always welcome. You can also take the material and run your own workshop as well. But I think the best thing is that we do it together because we have experience. Also, if you want to translate the workshop material, very, very welcome. I always encourage the Spanish community to do that with me, so I can go to PyCon, or the Latin America PyCon there. I want to go there. Yes, and also organizing event. Like I said, all the materials are online. You can take it and run the local chapter, by yourself. You don't need us to be there all the time. But again, talk to us. We will help you. We will give you all the things that you need, answer all your questions. And the last thing is the financial sponsorship. So this trip that I go to Ghana. So Ghana is, well, the food in Ghana and everything is cheap, but going to Ghana is not cheap. So thankfully, my employer, Anaconda, so I work for Anaconda, by the way, support me to go to Ghana. And we also financed 30 participants of the workshop to join the conference and join the workshop. So people were very, very happy, very grateful that they get this opportunity, that they can go to a PyCon, go to learn something, and network as well. So if you want to give us any financial support, it's always welcome. Talk to us again. I can be reached on Twitter, or you can email us. If you find our website, you know how to contact us. So thank you so much, and that's it for me.
Very well done. 7 minutes, 25 seconds. So Nicola will invoice you for the 2 minutes and 25 seconds. He's really strict about that, I'm sorry.
Okay, hi everyone, my name is Mike. I'm a medical physicist in St. Luke's Radiation Oncology Network here in Dublin. I'm also a PhD student in UCD. And in this talk, I'll just present some of my work and where Python was involved in my research. So just a quick note that I do not have any computer science background. All my Python experience is self-taught. And so this will hopefully give you maybe some of the new Python users an idea of where you can take it just purely by exploring different packages and so on. So the goal of my project was to develop a treatment planning system for radiation therapy for cancer. And to do that, I used the two packages, Plotly and Dash, to create a user interface. So I don't have slides for this. This is obviously kind of last-minute preparation, but I do have a demo. So the main kind of purpose of this user interface is to bring in computed tomography or CT images of the patients into kind of the display. And this can be done by a click of a button and selecting the folder with the DICOM files that were mentioned earlier today. This brings in the images in kind of the three orientations, the axial, sagittal, and coronal views. The user can then kind of assess the images, and kind of you can obviously interact with the Plotly graphs and zoom in on the images and so on. The user can then bring in a structure set file, which is something that the radiation oncologists delineate, so they contour different organs and the targets that are to be treated with radiation therapy, and these can then be kind of highlighted on the image set. So then a region of interest is selected. So this is done by just kind of dragging the sliders and sort of cropping the image to the region where you want to simulate radiation therapy. And in sort of medical physics, we often simulate radiation therapy with Monte Carlo simulations. And so to optimize the kind of the running time of Monte Carlo simulations, we want to minimize the amount of kind of volume that we want to simulate. So once you have selected the kind of the region that you want to simulate, you can move on to tissue segmentation, and this is essentially where the HU values that were mentioned in the first talk this morning, this is essentially the grayscale values of the CT images, are converted to kind of material properties for the Monte Carlo simulations. So the user can kind of select one of the presets of appropriate materials for kind of head and neck regions, torso regions, or extremities. So the user can then click Create Phantom, and this will generate an appropriate file to run a Monte Carlo simulation. Finally then, in this interface, the user is presented with a treatment planning sort of environment where the patient's surface is rendered in 3D using, again, Plotly. And the user can then define this kind of red beam, which is representing the radiation beam to be simulated in Monte Carlo, using the kind of, you can move it around using the sliders here on the right-hand side in spherical polar coordinates. So once this is done, a Monte Carlo simulation is performed outside of this. There is optimized kind of codes that run sort of proper Monte Carlo simulations. And then I've developed a second kind of follow-up package then that takes the radiation dose distribution, which is essentially where the radiation spread into the patient if it was to be delivered in practice. You can take this dose distribution and then overlay it with the CT images, and this is obviously just a different set of CT images as an example. You can display it as a heat map. And you can assess the sort of the spread of radiation in real time, kind of in these images using Plotly. So another thing you can do here is you can export this dose distribution as a DICOM file, and this is something that was mentioned in the first talk this morning. And this is so that the dose distribution can be saved on kind of clinical patient record systems for future use and further interrogation with kind of the proper kind of clinical treatment planning systems that are a lot more advanced than this. So finally then I have kind of one more tab where the dose can be assessed per organ kind of basis, and you can assess how much sort of dose is delivered to different volumes of the structures that were contoured by radiation oncologists. The last tab is just kind of sort of in development, so there's nothing to show there. And just very quickly to finish off then, as I said, this was all kind of self-taught, so just to show you kind of how easy perhaps for the new users of Python, the Dash interface, I found it to be quite easy to work with, to create these kind of, in my opinion, beautiful interfaces quite easily. There's, I think, 4 main components in simple terms. You have like a HTML layout, which is essentially just defining the different boxes. So the actual code is several thousands of lines long, but just to give you kind of some snippets there. You define kind of boxes on the screen which define kind of containers where you place the different widgets, the buttons, the sliders, and so on. You can kind of choose different colors using CSS code. You then use dash widgets to position all these buttons and plots and so on. And then finally, you can use callbacks. So I'm sure advanced users are familiar, but callbacks essentially kind of allow you to interact. So they allow the widgets to interact with kind of the underlying Python code to do all sorts of image processing. So that's everything I have. Hopefully it was informative, and if you have any questions, I'll be happy to discuss anything afterwards. Thank you.
What? I have a question. What's your name?
Mike.
Mike. Sorry, what age are you, Mike?
I am 28.
28, right? You need to spend the rest of your life devoting yourself to becoming the senior director of technology in the HSE. If you went off in your spare time and built that, this country badly needs someone like you to step in and take the reins. That was outstanding. Sorry, I take another round of applause. That was a really good use of time. Absolutely outstanding.
Thank you.
Okay, great stuff. So, yeah, I'm here to talk about, my name is Jared Keating. I'm here to talk about yournewsheadlines.com. This is a side project I was making. So the idea was, I used to subscribe to a lot of news sources, and with big news item would happen, you'd get 10 different alerts. So I said, there must be a solution for this. So what I did was, I went off and I got all the RSS feeds for reliable news sources. I compared them using the fancy Levenstein algorithm, which basically just compares the strings. And if two sources are the same, then I publish them, two or more sources the same. So the original idea was to make this into a Twitter bot, but that was making a Twitter bot as a PIA. I'm not making any money from this. This isn't like a startup, but it costs me money at the moment. So yeah, the goal was just to learn some web dev and build something I might find useful for myself. Kind of Wordle was kind of a big inspiration because Wordle's fun, and the guy did end up selling it for, but anyway. Okay, so the website's live. Yeah, so the big news at the moment is Banksy did a new mural in war-torn place in Ukraine. Yeah, you can visit the websites there, and yeah. What other features do we have? We have, yeah, you have settings, so you can say, okay, I only want to see places from 3 sources, and you'll get places with 3 sources, and then the various sources can be seen there. So very simple website, but yeah, look, it was a bit of fun. Yeah, what's the tech stack? Uses Python, obviously. I use Bulma CSS for the CSS. Flask, obviously, Flask for the web stuff. Feed parser just for the RSS feed. Postgres database. It's running all in Docker containers. Use Circle CI for the CI. AWS EC2s and the ECR, not any fancy cloudy stuff, no ECSs or Kubernetes or anything else. Cloudflare for, whatever, security stuff, and GitHub for source control. I do actually use, even though it's a side project, I like CI/CD stuff. So again, using Circle CI, I do all those check for pile into MyPy tests, run through static code analysis. So it does have like a 1-button deploy, so you press 1 button, builds all the containers, pushes it onto production. Cost, just so if you are doing side projects, they actually are quite cheap these days, which is great. Back in the olden days, you used to have to buy a server and stick it in the side room. So the domain, probably, yeah, €9 a year. Then EC2 was, I think I got a tiny instance of EC2, it was biggest expense. Cloudflare is free, ECR is very cheap, Circle CI is free, GitHub free. So there's lots of free services out there if you are doing side projects and fun stuff. So what I learned, front end is hard. Yeah, I spent ages trying to get the mobile versus the desktop thing sorted out. Bulma says it supports both, but in the end, I just had like, I have a Flask says, okay, it's based on the user agent. This is a mobile, I'll send off this template. This is a desktop, I'll send off this template. So yeah, Bulma's nice, very easy to use. If you want to push it, it kind of gets a pain in the arse. Yeah, 0 JavaScript was kind of an idea because I'm not good at JavaScript. There's a little JavaScript for the share button, but basically it's all Flask templates. So it's not like cool, new, modern stuff. I just try to keep it simple to get it out there. Yeah, I'm a big believer in automate everything. So it's 1 button deploy, so actually if I didn't have one button deploy, I would never ship this stuff and I would never put it out in public. I got a few visitors, very little. So
You're
yeah,
about to get a whole lot more.
Hey, that's the okay. So next step is IPO, of course.
Sorry, those days are gone, buddy.
That crypto money. So yeah, in conclusion, visit yournewsheadlines.com. Yeah, make your side project and ship it and have fun with making side projects. It's very easy these days. And then your conclusion is tell your friends about yournewsheadlines.com. So that's yournewsheadlines.com. Okay. If you want to contact me, I'm at vfxchair.com. Yeah, we're not allowed to mention Twitter anymore. But yeah, okay, cool. That's it. Yeah, thank you.
Well done.
Okay, so this is basically impossible. They have entire conferences dedicated to this topic. So I'm going to try and fit an entire conference into 5 minutes. OpenStack from 10,000 foot. I'm Stephen Finucane. OpenStack from 10,000 foot. Stephen Finucane, software engineer working at Red Hat. I've been working on OpenStack up until about last year, and I've since switched to working on OpenShift on top of OpenStack. OpenStack is a cloud platform. Hopefully most of you have heard of it. You can think of it like AWS or GCE or something like that. Couple of key services in it. Nova is your compute engine, which manages the lifecycle of VMs. Neutron does all your networking in the back end. Glance manages images like your Ubuntu images that you'll boot your instance with. Cinder does volumes like block storage. And Keystone does things like project and user management. And we also have this thing called placement, which tracks how much CPUs you've used. You can use that for billing, this kind of thing. Nova's the kind of core thing that talks to everything else. A couple of these services can also operate by themselves. So you can use Cinder, for example, if you want volumes tied into, we'll say, your Kubernetes cluster, you want to set a volume service. We've also got a whole load of other services, Swift, which is object storage, designate for DNS, that kind of thing. I'm not going to go into those. Couple of common design features around OpenStack, and the reason I'm bringing it up here, it's all written in Python. Everything's Python based, and it's all Python 3 for the last 2 years or so once Python 2 died. In comparison to something like Kubernetes, we don't use anything cool like etcd. Everything is traditional relational databases, which is typically MySQL or Postgres. We use message queues to pass information between different services or inside in services, and then between the services themselves, we use HTTP. It's all REST and like very microservice-y architecture. And in general, something that Python actually benefits us in, most of the OpenStack services actually wrap other things. So we'll say Nova doesn't actually really do all that much itself. It just wraps, we'll say, underlying hypervisors like Hyper-V or libvirt or VMware, whatever else. And then if anyone here has actually used OpenStack, you'll know that upgrades are traditionally a horror show. They've got better, but they're still not great, and the documentation is terrible, which is why people need to go out and give presentations on it, because they're better than the docs. Complicated diagram, not going to go through that. How do I get an OpenStack? So you can find public cloud providers, things like VexHost and that, Rackspace and so forth. You can use a private cloud provider, which is basically work. If someone in work happens to have an OpenStack instance, you can use that. Or you can deploy it on your own little home lab, a Raspberry Pi cluster, and so forth. How do you go about doing that DIY? The most common thing is DevStack. Don't read the source code for DevStack. It's a massive bash script. Yeah, I'm surprised it's still alive. Cola's a lot nicer. That puts everything into Docker containers. OpenStack Ansible obviously deploys with Ansible. And then O, don't look at that either unless you're paying Red Hat. Here's a local.conf file. You'd pass that into stack.sh, which is the DevStack, we'll say, entry point. That'll run a whole load of bash, and at the end, you'll be able to use systemd, because it runs on Linux, obviously, to query the status of your various OpenStack services and stuff like journal control to get your logs. And then once it's deployed, how do you go about using it? You've got Horizon, which is a nice, pretty GUI, but I haven't used that in years. You've got a whole load of command line tools. OpenStack Client is probably the most likely one that you'd see. This is all written in Python. OpenStack SDK, again, Python-based. Gopher Cloud, if you've moved on to new things. And then you can also use applications on top, like you can deploy Kubernetes on top of an OpenStack cluster quite easily. All Python-based, like I said, the clients and the SDKs. You install those, you give it a nice little utility to talk to your OpenStack instance. You can also do it all programmatically with the OpenStack SDK. Loads of docs available there, even if they're terrible. There's a lot of them at least. The source code, OpenStack is a bit weird. We don't do stuff in GitHub like Kubernetes does. We use a tool called Gerrit for our code reviews, which is amazing if you've used it, and it sucks if you've never used it. We don't use Slack either. We're still using IRC, Retro, and we also use mailing lists as well. So there's a lot of ways of contacting us. I'm around for the rest of the weekend. If you have any OpenStack questions that aren't bug related, you can catch me in the hallway. That's me.
Thanks very much.
I assume that everyone is laughing not because of his jokes, but because of my slide. And
No, we get it. We totally get it.
Cool.
Who would log squared?
Yeah. So a while ago, I saw this tweet. Sorry, don't mention it. I saw it on the social media. And I thought to myself that it's actually a very nice idea that we can use emojis to express some stuff. And I'd like to introduce you to this concept that please use emojis in your documentation. And it helps at least to speed up your creation of good documentation and other people finding out what you're trying to say. So here is an example of the same basic concept where I print some stuff from dictionary in a different ways. And if you look on the left-hand side, you can see that it's kind of hard, especially for a beginner or someone who is not familiar with how Python works, to find out which line in the output below corresponds to something in the code above. But if you look on the right-hand side, we can see that every line has a particular emoji, and you can sort of quickly find it up there. If I want to achieve the same thing without emojis, but on the left-hand side, I would have to open like a photo editor or something, add maybe a box and maybe some arrows and something. I can do it like once or twice, but I would never do it like all the time in my documentations. But if I use some emoji picker, or you can use rough emoji on Linux, or press some buttons on Mac, and it will do it automatically. And then you can squeeze it in your documentations, people would be happy. And if you put stuff like nice animals, they're usually very happy, especially if they read like your Jenkins logs or something, and they sudden emoji appears, they at least brightens the day. So yeah, that's the whole message. Use emojis. Emojis are fun. Use speakers, and yeah, I need to stand up. That's it. Thanks.
Thank you to all the great talk and speakers we had all day, and to all the delegates. I think PyCon Ireland want to be a nice place where you can become a speaker at conferences. It's not something you do on a whim, except for a lightning talk, obviously. But it's something maybe you should consider. Even if you're shy, even if you're a beginner, even if you believe you have nothing to share, you have way more inside you that you know about that. And of course, before you will show up to maybe a little national conference like ours, or maybe to a bigger conference like the EuroPython or the main PyCon in the US, there is kind of a mini career path to do that. It's a real career boost. It's a nice way to give back to the community. It's a nice way to give back to an ecosystem that's providing part of your job. So it's really a nice move. So what we've said now for a few years, I realize that our page is a bit outdated, is that in January, we provide for a full Saturday a professional coaching for 8 hours
to people who want to step up and become speakers. So it's tips, tricks about delivering your talk in person in a room, remotely through Zoom, the way you set your camera, your lighting, all the little, know-how. Then you can be coached and paired with one seasoned speaker from our committee, and we'll program you to one of our monthly meetup. Monthly meetup are or are not recorded, depends, but that would be the stepping stone for you to practice your talking and sharing skills. And you'll get feedback, and you'll have this in a, well, I would say a comfortable environment among friends. And once you build up some experience, maybe delivering a couple of talks in monthly meetups with our user group or other user groups, then you find more confidence to deliver a presentation in your workplace. And then you have a background to say, when you apply for a national or an international conference, to say, okay, I have delivered talks about this, about that, and I have recordings, and I have something to back my claim. And then you can grow in that world. It will grow you professionally, because when you prepare a talk, all speakers here will share with you that maybe you talk something that you were enthusiastic about, but you didn't know so much about. But because you're scared of the Q&A session, you will be over ready, 300% over ready, and then you know way more about that subject that you ever know. You would need to know about it, and you will have done great progress. So we have this program. We want that to be not hush-hush, but we don't want more than 10 people, because it's a lot of one-on-one coaching. So we can have our program of monthly speakers. So that's our win. We pay for the professional coach. That's your win. We only want a little symbolic thing to avoid the no-shows. And that's it. That's it. All you have to do is go to the PyCon Ireland website, find a coaching program section here, and register your interest. And then, if you don't know what to talk about, why you should do, and I'll let you do the reading. So it's a little point to read a slide or a screen here. And we have ideas of talks you could, maybe pick up from that list, or maybe you want to add to that list. We're taking your contribution. So that's it. We want to be a nice place for launching the future generation of speakers. I'm pretty sure we have a couple in that room. So please, do stand up. That's it.